Hey Scarlets, welcome back. Here we are. It's kind of crazy, not very good at this yet, so please be kind. While I've been gone though, I've been working on my chemistry jokes, so I got one for you. What should you do if no one laughs at your chemistry jokes? Keep telling them until you get a reaction. Pretty awesome, huh? Don't worry, there'll be a lot more coming at you. So what are we up to this week? This week, what we're going to do is we're going to kick off by going over and finishing up what we didn't get to in quarter 3. So if you look at where we left off, we were talking about solutions chemistry. So we had looked at molarity and how you calculate out molarity. Concentration is another name for that. We looked at single replacement reactions and we tried to answer the question, are you hot or not? And looked at how elements, they don't view each other like we would. We think that copper and gold and silver are really awesome, and they think they're yucky, and they like things like lithium and calcium and stuff like that. So you guys learned about how you could use the activity series to predict whether or not a single replacement reaction would happen. So we're switching gears now, and we're going to look at double replacement reaction. This is when you have two couples and they switch partners. And what we're going to look at is, more importantly, solubility. So solubility, one of those S words again. My goodness, there was so many in this unit. So if something is soluble, that means it dissolves, and that means that there's no precipitate, and so we label that compound as AQ. If something does not dissolve, it's called insoluble, and we label that as S. So we're going to look at how all that stuff works. So to get started, just going back quickly, double replacement reactions, that's when a metal replaces a metal and a non-metal replaces a non-metal. So when you make the two brand new compounds, positive and a negative, you never have two negatives together, you never have two positives together. And you're going to need to use your ion sheet and use crisscross applesauce to figure out what the two brand new formulas are going to be. Once we get that figured out, we're going to look at solubility rules so that we can label those two brand new products as either AQ or S. So there's two types of double replacement reactions. One is called precipitate and the other is an acid-base reaction. In a precipitate double replacement reaction, one of the products ends up being a solid and the other remains AQ or aqueous. If both products are AQ or aqueous, then no reaction happens. The other type is called an acid-base double replacement reaction. So when your AQ starting reactants are acids and bases, what will happen is the products that you'll get is water and a salt. A salt in chemistry means an ionic compound. So if one of your products ends up being H2O, so if we take that hydrogen ion mixed with a hydroxide ion, they come together and make water, that is going to be a liquid. That's still considered a reaction, and the other one will stay AQ. So how do we know if a precipitate forms? We have what are called solubility rules or a solubility chart. So if you look underneath your resources, there is a solubility rules chart for you. What it does is it gives you the rules. So what you do is you look at the ions in the two compounds that are formed. If one of the ions, according to the rules, says you're insoluble, then a precipitate forms and a reaction happens, and you label that S. If you look at those ions and both of them are soluble, according to the rules, then the state is going to be AQ. So here's what your rules look like. If you look at the top, you'll see all the ions that form soluble or AQ. So what you do is you look at the ions that are in your compound. If they are either a group 1 ion, they're ammonium, nitrate, acetate, hydrogen carbonate, chlorate, perchlorate, or halides or sulfates, they're going to probably be AQ. The only exceptions for when they wouldn't be AQ is if you look down where it says halides, that's your chloride, your bromide, and your iodide. If one of those three is combined with silver, lead 2 or mercury 2. Even though those halides are usually soluble, it's going to end up being a solid. So for example, if we look at silver chloride, chloride tells us it's going to be AQ, but the exception is silver, so that's actually going to be a solid. Same goes for sulfates. Most of your sulfates are going to be aqueous unless they're combined with either silver, calcium, strontium, barium, or lead. Now, there are only three three ions that are gonna give you solids. So carbonates, chromates, and phosphates are gonna be insoluble, unless there's the exception. If they're combined with either group 1 ions or ammonium for your carbonate, or they're combined with group 1 ions and ammonium for your chromates, and the same thing goes with the phosphates, then even though they're a carbonate, chromate, or phosphate, so they should be a solid, they're gonna stay AQ. So our first one was HNO3. So what we're gonna do is we're gonna figure out where those two ions are on our chart and see whether or not they're AQ or S. So what you do is you look from top to bottom and see if you can find either H or NO3 on there. Look at right here, nitrate, NO3. So that means that when you have a compound that has nitrate in it, it's always going to be AQ because there are no exceptions listed here. So that means our hydrogen nitrate is going to be AQ. Okay, now we're going to go back and look at silver and chloride. And again, start from the top and look down. Do you see either silver or chloride? Look right here, chloride. So it's supposed to be AQ, except when combined with silver, lead and mercury, and we are combined with silver. So instead of being AQ, this combination is going to give us a solid. So if we go back and look at those solubility rules, we can determine if those two things are either AQ or solid. So let's start by looking at the lead chloride. So again, look at your ions that are soluble for AQ and go down and see if you can find either lead or chloride. And if you look right here, chloride is there. So chloride is a halide, so it's typically AQ, except when it's combined with lead. So this one is going to be your solid. Now let's look at barium and nitrate. And again, you start from the top and look down and see if you can find either Ba or NO3. And if you look, third one down is NO3. There's no exceptions, so that means that one is always going to be AQ. So now you know how to label your compounds. Okay, so here are our two substances, and we're going to look at our solubility rules and figure out if they're AQ or solid. So again, start at the top, work your way down, and see if you can find either iron. That's a terrible arrow, sorry about that. Or hydroxide. So if we look and go down, oh no, I kind of messed up here. There should be hydroxide down here. I'm so sorry. I apologize. That's my fault. I didn't realize it cut it off. Should be hydroxides down there, and then it'll have the same exceptions. So if you look at your actual resource sheet, it's going to have hydroxides there. And so iron is not either a group 1 ion or ammonium, and so that means that this will be your solid. And then if you look, for the second one, sodium and sulfate are both listed as being AQ. The only exception would be if it's with one of these, and sodium is not one of those. So this is going to be AQ. So let's look at a couple examples. That'll maybe make it a little bit easier. So first thing we're going to do is we are going to switch our ions. Outside ions go together, form a new compound. Inside ions go together, form a new compound. And we need to use our charges to see what they should be. So if we look, hydrogen and nitrate should go together, and chlorine and silver should go together. And this one darker. Okay, so if we write this, I'm going to first put the hydrogen and I'm going to put the nitrate together. Hold on a second. I'm having issues with my pencil here. Sorry, first time. So I got to figure this out again. So let me go back to this and we'll go to, and I don't know why it thinks it's a pencil, because it's not a pencil. We're not doing a pencil. And we'll try doing this again. Sorry about that. Let's see if that makes a difference. It's not. I really don't like that. No, no, no. There we go. Goodness sakes. Let's erase this. Okay, sorry about that. Whew. Tell ya, this is a whole new ball game for me. Here we go again. I was having issues with my pencil. So we're gonna put hydrogen. Oh, come on now. Here we go. We're gonna put hydrogen and nitrate together and silver and chloride together. So we've got HNO3 plus we've got silver chloride. Okay, now I'm gonna go look at my charges on my ions sheet and make sure that I don't need to add any subscripts. And if I go and do that, I'll find that hydrogen is a +1 and nitrate is a -1. So since they have the same charge, we don't have to add any subscripts. And also with chloride, it's a -1 and silver is a +1. So again, I don't have to add any subscripts. So now what we're doing is really focusing on trying to figure out what are those little labels gonna be? Are they gonna be AQ or are they gonna be S? So to do that, we're gonna have to go back and we're gonna have to look at those solubility rules. So going back to this, I would label this AQ. So since that is a solid, we're gonna label that with an S. So since there is an S there, that means that this is a reaction that happened. So the silver chloride is insoluble. We label that as solid. The hydrogen nitrate is, the silver chloride is insoluble, which means it's a solid. The hydrogen nitrate was soluble, which means it's aqueous. So this reaction happens. Lastly, then you just want to go back and balance it if you need to. So if we look, it looks like we don't need to add any coefficients to balance it. So this is good as it is. I'm just going to go back and erase all my messes. Never mind, I'm not going to. We're just going to move on from here. Okay, next what we're going to do is the next one, number 2, lead nitrate and barium chloride. So again, what we're going to do is put our last and our first one together. So the lead and the chlorine are going to go together, and the barium and the nitrate are going to go together. Remember, we always write the positive one first. The metal goes first. So that means that lead is going to go with chlorine. Notice how I didn't bring the 2 over there because the 2 was there in order to balance it. Now, I don't know if I need it yet or not. And then now I'm going to put the barium with the nitrate. And again, I'm not adding any subscripts yet because I don't know if I need them until I go look at my ion sheet. Now, if we look at our ion sheet, we're going to see that lead can be a +2 or a +4. If we look who it was originally with, nitrate, the charge of the nitrate is going to help us because we learned that you could do what's called reverse crisscross to figure out the charge. So if we do a reverse crisscross, that means that lead was a +2 and nitrate was a -1. And if we look on our ion sheet, nitrate is a -1, so this is true. So this wasn't reduced or anything because you had coefficients that could factor into each other. So if we look then, that means that lead was a +2 and nitrate was a -1. If we look at our ion sheet, barium is a +2 and chlorine is a -1. So now when we look at lead and chlorine, chlorine is a -1 and lead is a +2. So this is a +2 and this is a -1. Since the charges weren't the same, we have to crisscross, which means this charge comes down and that charge comes down and becomes our new subscripts. We don't write the number 1 for lead, but we do write the 2, and so this ends up being PbCl2 for that. And I'm just going to erase this so it's not as messy. So that's lead chloride. Now we can do the same thing for the barium and nitrate. Barium is a 2 and nitrate is a -1. So the 2 needs to come down and be the subscript for the nitrate, and we'd have a 1 for barium. So that's like we did before. The new part again then is to figure out what are those states. And to do that, we have to go back and look at those rules. So we decided by looking at our chart that this one is going to be a solid and barium nitrate is going to be a Q. So that reaction is going to happen. And now we need to go back and we need to actually balance our equation. So to balance, if we look at our leads, they're balanced. If we look at our chlorines, they're balanced. If we look at our nitrates, they're balanced. And if we look at our bariums, they're balanced. So we don't have to add any coefficients to this one. So let's move on to number 3. See if you can go ahead and crisscross applesauce. See if you can figure out what those 2 compounds are going to be. Okay, so hopefully what you came up with was Fe and OH plus, and about that, Na and SO4. Then we need to look at our charges to see whether or not we have to crisscross. Iron can have more than one charge, but it is paired with sulfate and it's a 1-to-1. That means whatever sulfate's charge is, iron's is going to be the same. So if we look up sulfate, we're going to see that sulfate is a -2, which means iron must be a +2. Sodium is a +1 and hydroxide is a -1. So when we go to crisscross, that means that the iron and the hydroxide are going to cross because they are not the same, because we have a 2 with a 1. So that means that we're going to need to put parentheses around the hydroxide and put a 2 right here. And then if we look at the sodium and the sulfate, sulfate's a -2, sodium's a +1, which means that sodium is going to need a 2 right here in order to balance. So that's our crisscross. Now what we need to do is figure out our states. So we have to go back and look at that solubility chart. Okay. Oops. Sorry about that lag time. I'm still trying to figure out this program. Hopefully the next one will be much better. It's kind of glitchy, but we're getting there. So what are we up to this week then? This week's assignments is, now that you went through this, what you're going to do is complete the double replacement reaction sheet. So what you're going to do is predict the product. So you're going to write those compounds. You're going to have to use that ion sheet to make sure that you have the right subscripts so that you can go back and balance it correctly. And then you're going to label your states of matter. So it's either more than likely going to be either AQ or S. The only exception would be is if you happen to make water, then you're going to label it as an L. It helps to use Cami for this because then you can just write right on the worksheet. You don't have to sit and try to write it on a separate piece of paper or print it off and then take a picture of it and try to turn it in. So please, if you haven't, go read through the instructions on Cami and how to add that extension onto your Chromebook. I also included a video so you could go see some of its features. So if the assignment itself isn't already a PDF, what you do when you go to open it is it'll let you choose what you want to open it with. So you're going to want to choose Cami because then you can write on it and then you can just turn it in with your writing right on it and you don't have to sit and go through the hassle of everything else. Once you have that done, you'll probably want to go ahead and also what you'll really want to go do after that, listen to me, I haven't figured out this whole editing thing yet. We'll get there, peeps. Then next, what you're going to do is the reactions practice quiz. Same thing, use Cami, it's much easier. Then what you can do is start working on passing the reactions quiz. So please follow that form there. You can retake it as many times as you need to pass. I do highly encourage that you actually do your own work and don't just randomly click stuff. We're going to be able to see if you are just whizzing through it, and then I will make a note of that and you'll end up with an email home to your parents. I may also say, hey, forget about it. I'm going to make you a new quiz. So please make sure you're really doing it yourself. You also have an opportunity this week to do a retake for both the vocab unit 7 and the molarity quiz. It's a one-time shot because you already retook both of those. And if you didn't make them up and you've had lots of time to study. So what you need to do is, if you need to retake those, you just get to take them once. That score then goes into your third quarter grade. You have to retake it by, we're going to change that. We're going to have you retake it by Sunday, 11:59 p.m. We do, however, want to make sure that all your third quarter work is done and turned in by 11:59 on Friday, April 3rd, because you've had lots of time to try to get a hold of myself or Mr. Degner if you're in our co-taught class to try to figure out how to get that stuff in. So we're not going to accept any more third quarter work after Friday, April 3rd at 11:59 p.m. There was links that were sent out on Google Classroom, and so a lot of you have contacted and figured out how to get that done, so we are holding fast to that deadline. I think that's it for now. I have some office hours put on the calendar there so that you can go ahead, jump in on one of those if you want to talk in person, if you've got questions. Also, please go through and read through the syllabus and so you can see exactly what it is that is expected of you, and we're just going to take this one step at a time. Have a great day, stay healthy, social distance, wash your hands.